Hey, what's going on? We have a Superior Instruments Model 670A voltage meter tester in front of us. They started making these models in 1953, maybe a little bit earlier because there was a revision in 1953. That's where I'm pulling the date from. So this thing is 70 to 80 years old, at least 75. So don't know how well it works. I never plugged it in. It's not a vacuum tube meter, so I think it's a little bit more basic. But it will do pretty high current. If you can see down here, all right, 7,500 volts, 1,500 volts. I don't know if I would test 7,500 volts or 1,500 volts with this ever, but it says you can do it. And I think for today, all we're going to do is change out the battery, the way the battery's set up. We have one bad resistor. It's actually just broken, and then there's two caps in here that we're going to replace, and then we'll go from there. I've already tested all the resistors. Everything is within specs. I don't like the way they did the resistors in here. I'll show you when we get in there. So let me get this pulled apart, and we'll see what this looks like on the inside. Alright, so here we go. Here it is. I mean, you can see there's not a whole lot going on the inside. I mean, if you took apart a BTVM, right, you have a lot more components inside. Maybe just a sheer component count. Maybe they're pretty close, but I think the vacuum tubes have a little bit more going on inside of them. There is a mixture of types of resistors in here. Let me see, like these. There's a couple of these. You have these. Let me get these little dog bone ones right here, and then you have your carbon. I'm assuming these are carbon. Normal ones that you normally find, and then you have the old school, is it a mica, is it not, resistor right here. I actually soldered this to the battery, and it broke when I got it. It was broken right here. So this is the one resistor we're going to replace with a new battery. And then if you notice, you have you still have your selenium diode over here, a rectifier. Most people recommend that you change those out as soon as you can, because sooner or later they will go bad and possibly catch fire and produce a lot of toxic smoke. And that's what I've heard. I've never seen one go bad, but I haven't been doing this as long as some of the other people out there. So what I'm saying is they're probably 100% correct. So if you have the know-how to change these out, I'm told it's pretty simple. I would change them out. You also have this other rectifier right here. I'm not sure what to call that one. I don't think that one is a selenium rectifier like the one up here. Let me pull the schematic down here. And so the selenium, right, it's going to be this one right here. If I read the schematic correctly, right, it's going to be that one right there. And then you have one that they have HS red dot, right? I guess a red dot tells you which side is which on it, or something, to orientate it. So you have this one. So I don't know if this is, don't know what that one's for. If anybody knows, I'd like to know the actual name for it. It is wrapped up all in black. And from my understanding, when you know, selenium diodes or rectifiers, they pretty much the basic shape right here. So this one is different. So I'm very curious. I'll probably look up a little bit more later on. The two capacitors that we're going to replace is this one and there's one right here. They're both paper. So we got a little transformer. We'll make sure that's working. I did order an actual holder. I don't like this setup right here. I actually ordered a little battery holder where you push down your battery. It's got the little spring clip inside of it. But I had a I had a pretty big order coming from Newark Electronics, and it's lost. It made it to my town with UPS, and that was a week ago, and it's still not out for delivery. It says delay, so I have a claim in, so I don't know when I'm going to get this in. So I'm going to go ahead and order, I'm going to go ahead and replace it just the way they have it now, and then when I get the battery holder in, it should be pretty easy to change out. So you can see that inside of it, there's just not a whole lot. I'm not complaining. You know, it does make it kind of nice not have to deal with so much. And then on the front side, alright, ohms adjust, high ohm cap, all your ranges. If I was using this, right, I'm pretty much going to be using over here. So still has pretty good paper on it. Nice vintage look. Inside the case, not a whole lot, but that's pretty nice. Got some overspray in there. I don't know if someone actually tried to spray paint this, but that's probably factory. You know, wrap up your cords. The power cable to this is in pretty good shape. I mean, it still bends and it's not cracked. So I don't think I'll replace that. Maybe this one will go up on the shelf somewhere and just in a man cave. I don't know. So, all right. So I think the first thing I'm gonna do is get this pulled off. You just take these two bolts off right here, and go ahead and replace this paper cap on the back of it. And this is what's going to go inside of it. So that's a 0.05. Is that right? I'm sorry, 0.5. And we're going to put I think this is a 0.47 inside of it. I already checked the paper foil side and marked it, so that's where that black line is. And if you don't know anything about that, there's a lot of videos out there. I've explained it a few times in my videos, but there's a lot of good information out there. And then this guy is a 0.047. Now on the schematic it is labeled a 0.045. But I found that the schematic does not actually reflect how they built this on the inside. So this is what's going to go inside of it. This is a 0.047. Again, I've already determined the foil side. And some of the things that I didn't like about the resistors, right? In order to gain their values, so on some of this you have one section that's 750K, 75K, and 7.5K. And what they did is they just added, resistors on these legs until they got to that value. So when you're looking at it, you're looking for 750K ohm resistor. What you're going to find is 2 or 3 resistors to make up that value. So what I did, I went in and tested each resistor, wrote down the value, what was the total value of that, and did it compare to what it's supposed to be. And for the most part, everything is in line, close. I'm not gonna sweat it too much. Nothing was really out of tolerance, but I get nervous when things get to that. If it says 20% and it's at 19, how long before it hits that 20%, right? So I normally end up changing them. Same thing when they're at 10%. If they're 8 or 9%, or maybe even 7, I'll end up changing them. So yeah, all right. I normally use a nut driver on these, and not what I had, but my nut drivers are in the garage and I'm too lazy to walk out there and get them. for that size. I have some smaller ones in here. Alright. Fairly easy. Make sure I don't rip anything out. That's what it looks like underneath. The only thing that's going on there is this guy right here. So unfortunately, I don't think, where'd my little part go? I don't think the wire is going to reach through that hole to this connection, or this one through the other hole through the connection. So I'm going to have to cut these and loop it with the old wire. I don't like doing that, but that's what's going to happen today, and we'll go from there. So according to the schematic here, there we go. The ground for this guy, if we have our 0.5 right here, so the ground is going to go to, well, I'm assuming the ground is going to go to the pot. What do y'all think? I think that's the right way to do it. I don't see any ground symbols on the schematic, so I'm assuming that the other side of this pot is going to be a ground. Let me double check. This is the first time y'all seen my videos, right? I'm learning this stuff as we go along in this video. I started out with very limited basic knowledge on this stuff, so some of these things might be common knowledge for a lot of people, but not always for me. Let's see. Yeah. So this part right here is the ground. All right, so my hunch was correct. The little arching thing is the ground side. You like that technical term, archy thing? But all right, so that's going to go in there like that. So that's actually gonna, so this connects, this wire at one time connected to this rectifier. And that rectifier is the positive side. So the negative is going to go on this side. So we'll go ahead and cut this guy out of there. I'm going to give myself a lot of room for this wire, and I'll cut it down later. There we go. So on the schematic, so okay, again, this is a 1-point capacitor, right? 400 paper capacitor. Let's see if I can get that in there. There we go. 1.0 400 volts. The schematic says that it should be a 0.5. That looks very original. So what do? Do I put this guy, or do I put a 1 in there? Let me pull a 1 out. Can't believe I had one of those. So I think I'm gonna go ahead and replace it with a 1. I mean, this was a 1. It was already in there. This is a 1, but I'll have to determine the foil side on this. So, all right, give me a second. I'll be back. All right, I got the old paper out, paper cap, and I went ahead and bent this to where I needed it. So I'm going to loop it around here and trim all that back when I solder it in. And then come up here and solder this guy. There we go. And solder this guy in and put this wire back. Might put a shield, a little bit better shield over this wire. I don't know. Now I need to cut this guy out and get this little guy fitted up. You can see that on the old paper caps, right, this is the foil side, it even says it outside. So I'll just line it up with that. But you can tell it's not going to reach, so I'm going to have to do the same thing. I'm going to have to use some of this lead coming off of here and loop it. Alright. Again, I don't like doing it this way. Some people do it all the time. Oh, you know what? I screwed up. I didn't put that sleeve back over it. If I can get that out of there. I know my hands are in the way. Sorry. Alright, I think I'll solder that first. And I'll see if I can't get But before I do that, give it a little bit of protection. Alright, I'm going to go ahead and solder this in first, just so I can be done with it. I got my bigger blade on this soldering iron because I intended to solder the battery first, but I think we'll be okay. anytime I solder, I got to get my glasses because I can't see. Can y'all see that? Yeah. Well, that sucked. That's not what I wanted. Don't know if I like the look of that. Looks kind of amateurish. Okay, but that's what I am. All right, we'll go ahead and solder this side on first. You know, I ordered this Flux, right? Heard really good things about it. I thought it came with some kind of applicator on it, and it did not. So I'm gonna show you what I've been doing. Don't make fun of me, but I've been using this as like a eyedropper, or just you know, I think I will put something on there. Just to give it a little bit more abrasive resistance on around this diode or rectifier. There we go. Here we go. Alright, let me get this situated here. I'm going to put my fat head in front of this camera to see it. So let me get that done. Alright. Let me get this guy soldered. What a mess. What a mess. Throw a little flux on there.